Hey everyone, hey Nelly, hey Aaron, how's
And
everybody today?
Well,
yeah,
Yeah, we've got a couple of new guests this week for anybody that's joining along. Matt is stuck with a specific work event today, so here he is. He's popped in for a little bit. Hey Matt, we've just gone live.
hey, perfect. I've got poor internet and I'm not in my shed, so I'm over in Sydney today.
Yeah, so yeah, we've got Nelly and Aaron along today. Maybe I'll let Aaron introduce himself, and then Nelly introduce herself as well. And say anybody in the audience, let us know where you're from and how things are going today at Post Reinvent.
Cool. Hey, I'm Aaron. I'm a partner solutions architect at AWS and based in Melbourne.
yeah, I'm Nelly. I'm a solutions architect. I think I am. I'm not 100%. I've been in this role for 18 months. I'm not 100% sure I'm still there. But yeah, I'm in Melbourne right now. And yeah.
Yeah, awesome. So Matt and I have been talking about a little project that we built over the last sort of few weeks, and it was an extension on one of our earlier shows where we built a series of LEDs, and we enabled people to interact with the APIs and turn that on and off. And we'll find the YouTube link to that earlier. And we had interestingly had somebody in the audience write a quick little script and be able to turn on and off that motor and really irritate me quite a lot, which was quite a lot of fun. But yeah, it was a really fun interactive session, and we extended on that a little more. And we built this concept called Devember tree, and maybe I'll let Matt introduce that while I grab a couple of the links and get myself ready here.
Yeah, I guess the December tree was, we've got this AWS event called, the 12 Days of Devember. But really, it was because we've been away from friends and family for so long, we decided that we wanted to effectively have some form of way to interact with them. We're going to send everyone Christmas cards. We always do. I've got my Christmas tree up. I'm crazy about Christmas, but it's is there something fun that we can do to bring people together? Whilst we're all living digitally, right? We don't get to see all our family and friends that we usually do on Christmases. So how can we bring everyone together? So that's kind of what started the idea of the Devember tree. Nelly and Aaron have jumped in as well, and they were there from the very start, helping us build this idea. Both of them have done some really cool work, and we're going to go and see all of that today. It's quite a large solution, so there's lots and lots of different aspects. So it should be interesting. We're going to touch on SQS, SNS. We're going to touch on API Gateway and Lambda. We're going to touch on Amplify. We've got Raspberry Pi. We've got all these bits and pieces that we kind of want to bring everyone through today. But maybe to start, should we show everyone what the Devember tree looks like first up, Paul?
Yeah, I think so. We'll give everybody a look at what we're doing. Do you want to share your screen and drive through it, Matt? Or do you want me to?
I'm actually, let me show you guys this, right? I was showing Aaron and all that earlier. I am literally streaming with none of my gear today from an iPad.
So maybe then I'll do it?
Yeah, I think that's a good idea.
Okay. All right, let me just get a clean browser up and ready. Okay, so this is the URL for people to go ahead and click on that and have a look at the URL. But what I'll do is I'll share my screen now, and I'll take everybody through what it is that we've been building. So I think Matt said December tree, but it's actually a Devember tree. So
Devember tree,
it's all
that's right,
specifically around, it's all specific around being a builder, building something on AWS, getting involved, trying out new services, and having a bit of a fun post Reinvent towards the end of the year. So we decided to build this IoT Christmas tree, and enable people to interact with the lights, to be able to turn those on and off. We built a small domain specific language to enable people to provide a pattern to turn the lights on and off in a certain sequence. So if they wanted to animate the lights in a certain way rather than just individually clicking on and off one of those lights there. We wanted people to be able to see something that occurs digitally, or something that you can interact with on the on the internet or on your mobile device, your browser, your desktop machine, whatever that might be, but see that take effect and take a change in the real world and see what happens there. But we also, as Matt said, thought that it would be, reasonably fun to be able to provide a mechanism for people to have, send a message out to somebody and schedule that for a specific point in time in the future. And, that's why we decided to build up this little platform that enables all of those lights to turn on and off and to interact with that live. So you can have some sort of instant feedback and instant gratification, but also the ability to be able to schedule a message for some point in time in the future. And then for us to experiment on the back end with how we would, build a couple of different platforms that are, decoupled, but also provide us with some sort of security. I mean, opening up the ability for anybody to type any sort of message and display that live on a public forum. Obviously, we have to be cautious about what we're putting through there. Do we want to have some sort of AI that's going behind the scenes to look for, specific words or specific content and turn that on and off? But also, do we want to have some sort of manual process over the top of that actually enforces whether or not that happens? So this is the platform, and I can see that people are, interacting and turning the lights off as we're talking through here. Maybe what we'll do is, before we go into some of the architecture, it's pretty obvious, and maybe we'll start with the lights. But it's pretty obvious what's happening when you click on and off those lights. But what people might not have realized is that if I click on the red light, the top red light or something like that, everybody else is getting that update on their computer. So it's all handled by WebSockets, and then it's communicating to the back end. And Aaron worked quite a bit on that piece, making all of that work, and the light animator. So maybe Aaron can talk a little bit about that bit before we go into how Nellie's gone ahead and built the whole front end and the message schedule and so forth.
Sure. So like you said, Paul, it's all hooked up to a WebSocket. So it's using API gateway. It's using a Lambda, but instead of RESTful service, it's a WebSocket interface. So essentially, every time somebody connects to the client, so if somebody loads up the web page, we're storing the session ID or the client ID in DynamoDB. And then every time a click on the lights on the tree is fired off, it actually will then send it out to every client who's connected to the web page. And so basically, we can interact with each other, but also when it fires off the call back to all of the clients to show which button has been clicked, it also sends it to the API. So there is the RESTful API, obviously, to send to the IoT device to then trigger on and off. The more complex part of that is underneath the tree, you can see the little light animator. That's the DSL that Paul was talking about as well. So that's the domain-specific language. In this case, it's just a true-false array representing each of the lights on the tree, and then separated per line. And then for every line, that's 1 second. So if you put in multiple lines of true-false and then hit send animation, all it's doing is it's creating an animation frame. So using JavaScript to create an animation frame and step through second by second to fire that off, not only to the API to fire off the lights on the IoT device, but also to the WebSocket so that everyone can see the animation happening as we go. Like if I just chuck in an animation now and hit send anim, you'll see it on Paul's screen now flashing. So I've sent that from my connection. We can see it on Paul's screen. You can see it in the stream so that it's sending it out to everyone. We can interact with each other and we can interact with the device. And that's that was basically my part. Was I'm not as good as the visuals as Nellie is, so I just worked with Nellie to plug in my back end code into her front end. But so we're sending from Nellie's, and I'll let Nellie explain it. But we're sending from Nellie's front end with the tree that she created to my back end WebSocket, and then to Paul's API.
One thing before we go, I'm just amazed, right? We've got people from New York, Zimbabwe, Nigeria, Costa Rica, Chile, right? This is the first time we've actually had people from around the world control the tree, right? Like we did a bit of a test from people across Australia. Like it's pretty cool, right? Like you're talking to, a little Raspberry Pi in Paul's house, effectively, testing out his internet connection. But it's pretty amazing. So I thought I'd kind of refocus on that because I was just looking at where everyone was from around the world on the show today, and I'm like, it's pretty cool when you think about it. Go ahead, Paul, and I know Nelly, you want to jump in as well.
Yeah, sure. Yeah, I really like you, Paul, when you mention about reasonable fun, because I have absolutely unreasonable fun with that. So much interesting things. So I started with create React app, right? Like all the cool projects start, and I was thinking how am I going to create this tree, and I was trying to draw it in like my iPad, but it's what was an image which didn't scale very well and was heavy, and we don't want to really, have a performance problem. So I'm thinking I'm gonna do SVG, right? And I was trying to draw SVG, but it didn't really work. I tried different like online stuff, and they all been like so bad. And I just think I'm gonna do math, and I'm gonna draw this tree with numbers. And this did very well because the size of this tree is basically nothing, because it's maybe like 50 numbers, right? So I created this project, put this thing all around. How I'm going to bring it to life, I don't know. And I really wanted to, like, I don't have time, right? So I wanted to do something, and it's just work for me. So I was trying to amplify. So I created Amplify project, pointed to this code commit repository, and boom, it's working. That's me. No, not really. But it was so easy. I didn't even expect that. Yeah. And what else was interesting? Yeah, well, I created messaging. So you can schedule a message, and this is wonderful thing you can do, because you can like schedule a message, Merry Christmas to, and I don't know, Jenny, and tell her to come certain time, and she can see that. But we also wanted to, check what you guys put in there, so you don't, say thing you don't want to say in public, but because it's public project and it's publicly available. So we wanted to build kind of pre-moderation. So any of us can, approve messages you send. So it's all good and round. So I created first email validation through SNS, and it's worked very well, but it was slow. And then we didn't know who pressed what and did what happening. Then we built SMS, like through SNS, but it costed too much money. So we end up having Slack, and how I hooked up it from the beginning. So I have an API gateway with the, just a get method. And in Slack, there was one link, we just click and it's basically approved. I didn't consider that Slack have to click this link in order to create this little preview. So Slack was approving every single message, and we noticed it after a couple days. Yeah, so we have to rebuild. I had to rebuild it. So I created a new page, and even if it's Slack open it, it's fine, because you need extra one button. And thanks to Paul who noticed it, because I didn't.
I gotta call out, Nelly, that I think that's an amazing job that you did with the SVG. I obviously had to plug in my WebSocket stuff into the SVG that Nelly had created. I've never worked with SVG through state management in React like that before, and I think the novelty just of like each of those lights in itself is an SVG inside the SVG. So is a what do you call it, a polygon or a circle inside the SVG. The light on, the little white indicator that shows the light is on, is another SVG on the top, but all of it is, or another polygon, all of it's one SVG, and then the state of the tree all managed through state management in React. It was a very novel way of doing it. So big call out there.
Yeah, and it scales. You can see it looks good on any phone or wherever. It looks good on TV because it's SVG, right? I really like this part. And lightweighted.
It's really raining hard here, so it's hard for me to hear. But did you see that question from Late Runner Wins about why using DynamoDB to store session ID, Aaron?
Oh yeah, so essentially, because I'm using Lambda for the WebSocket, because it's ephemeral, so it'll only last for the time for that single request to execute. I need somewhere to store all of the connected sessions. So for all of the clients that connect to the WebSocket, so when the web page is loaded, it makes a connection to the WebSocket. Essentially, that connection's not going to be there for every single Lambda. So it actually, or the memory of that session is not going to be there for every single Lambda. So when a new Lambda starts up to execute a new trigger, so somebody's fired off a light press, it needs to look at the DynamoDB to pull out all of the sessions, so the connected sessions, and then it knows who to send it to. It's just the simplest way of doing it as a bulk send out, as opposed to having just to go and like store individual connections to the web app, and then fire off. If you were doing like a chat type solution, you might handle it a little bit differently. But in this case, I can just do a get all from DynamoDB and send.
Why you use Paul? Why use 2 Raspberry Pis? What the purpose of this?
I don't know whether you can actually hear me because it's actually really raining really hard. If you can, I'll just try to battle through it. Okay. Well, maybe what I'll do to help explain that a little bit more is I'll take you through a bit of the architecture of the back end. So I'll stop sharing that screen. I'll share a different screen, and that is. Let me bring that up in just a second. So I think somebody just sent a message through saying hello from Chile. So originally when we were putting, like, Matt, myself, Nelly, and Aaron and I, we built this within our own free time. So we pieced it together bit by bit, slowly but surely, and we came up with some sort of an idea of how to build it. Actually, maybe to take you through the original bit of that, I'll show you, like, I actually built the tree itself. So maybe I'll share that screen. And that might be interesting for people to have a look at what is happening there. So here's a couple of photos from Google Photos. So I'll bring that up.
I feel like a little bit uni project, right?
So what was that? Sorry.
It feels like a little bit like uni project.
A little bit of a uni project. It was sort of a bit of a hack, and we were sort of thinking about that early, about a month ago, when I found somebody that would CNC cut out like a Christmas tree out of thin sort of cardboard. Then I went ahead and drilled all those holes. I measured out where I should put that LED display, and you can sort of see that on the left there, and worked out how to use that matrix. A couple of the LEDs you can see there, and a couple of the gears. I was building something in the background that just happened to be overlaid on that picture there. Then I'll sort of go the other way to show it what I started with. Yeah, so then I drilled a few holes and I filed it out so that matrix would fit in the middle, and you can see I did all of that outside, so my bits and pieces were outside. I made sure that fit in there like fairly nicely. Then I plugged in all of the the LEDs and aligned those in a certain mechanism. Effectively, it goes from the top, which is LED 1. The second top green is LED 2, and that was the sequence numbers. I built it all the way through, and then I had to go ahead and do some wiring there. You can see this is the back of the board, so here's all the pin alignments that I needed to do. Bit by bit, I went and started to do a daisy chain so that every one of those LEDs would have a negative attached to it. And then for the positive to be able to engage and turn that LED on, I needed to have a specific wire that mapped to the GPIO pins on the back of the Raspberry Pi. So yeah, here you can see at the back, this is sort of the back of what it looks like. There's actually a small animation video. Here's the photo. So you can see at the back of the board, that's kind of what it looks like. There's a negative all the way through daisy chains. You can see that clip wire is clipping onto negative. And then that is all the photos I took. Then I took each one of the positive pins off each one of the LEDs and wired that back to a GPIO pin on top of the Raspberry Pi. So I'll stop sharing my screen there, and I'll share back the architecture piece that I was going to take everybody through and go back to explaining why the 2 Raspberry Pis. So First off, there's some complexity. So the solution is actually running across 2 AWS accounts at the moment. One of those AWS accounts is my home, my personal account. It's all connected to AWS, and I have a site-to-site VPN that enables me to expose like any type of application or service on my home private network back into AWS over that site-to-site VPN. So I have a direct connection that allows me to connect to any sort of service that I want to within the VPC in my AWS account, and anything within my VPC in AWS to connect to my home, subnet network there. Now that Christmas tree that you saw is actually in my shed. So if I was to sort of rotate my laptop around, and maybe I'll do that a little bit later, you would see that like I sort of have a bit of a homebrew set up in my garage where that Christmas tree is sitting on a bench. I then have an iPhone that is sitting in an older iPhone 6 that's sitting in front of that bench that's pointing at the Christmas tree. The iPhone 6 is streaming to Twitch, so that's doing a live stream into Twitch. That Twitch is embedded as an iframe with the source being the Devember URL that you've seen, embedded into the Amplify app and served out by S3 and Amazon CloudFront here. So actually, this here should be CloudFront. So that's kind of like why it is at home. Now, why the 2 Raspberry Pis? Well, first off, the way the solution was implemented was instead of using Twitch, so this is only a week ago, I was using an Android app on an Android tablet called IP Webcam, and that would allow the streaming of video that effectively was like an image that you would embed in your page and would distribute that image out to everybody, and it would just constantly update all of the time. And it looked like a live streaming video, but it was actually just an image that was kept, updating itself and pushing out that information. That worked really fine and worked great. And even really, really early on the series when we did that before, we had probably like 40 people or something streaming from that. And it seemed to work okay. But recently my ISP throttled my uploads. And so they cut the uploads in half. And when we did another test run internally at Amazon, it was so lagged that it was taking like at least a minute for the video stream to be able to surface to everybody. And it was causing all sorts of problems. So the API stopped working. So that's when I went ahead and switched that off to Twitch. Now, at that point in time, what was happening was on this first Raspberry Pi, I was running Nginx, and Nginx was acting as a reverse proxy. And the reverse proxy was exposing that specific image that was coming off that Android device, as well as reverse proxying the Flask application that was exposing that API. So that I had a target group sitting in AWS behind an application load balancer, and that was pointing directly to this Raspberry Pi running Nginx, and Nginx was reverse proxying the Flask application and the IP webcam into the solution here. So in effect, this is still running and still running the health check. What was that? Sorry, Nelly?
Do you have a diagram of it? Because it's already like, I couldn't figure it out.
I was not sharing my screen. That's super unfortunate. So yeah, I was talking through the diagram without sharing my screen.
Yay, that's better.
So I'll go back to it. So yeah, this is where you can see that iPhone 6 now. That's streaming directly to Twitch. Twitch is embedded into CloudFront here. And that's embedded into that Amplify app that you're seeing at the front end being served out by the internet. The Raspberry Pi here, which is running Nginx, that is keeping the health check alive. So I'm running the health check on that Nginx service. And that's just a legacy hangover. I can eliminate that and remove that piece of infrastructure. The target group here is pointing to that web server. So we know that, that the Raspberry Pi is healthy. So the second Raspberry Pi is which is running a Flask app. So that's a Flask app, which I can have a look at, a little bit later if we're interested to have a look at the code. But effectively, in that Flask app, I provision all the GPIO pins, so enable access to all of those pins and have a bit of a convention that says, from pins 1 to 12, this is what you want to do. And then there's an API that allows you to post directly to that API, and you pass across it an array of elements. And each array is just indexed, so it's 0 to 11. But effectively, that 0 to 11 maps to 1 to 12 on the lights. So if you were to turn on, index 0, you'd turn on this light. If it was index 2, you turn off that light, and so on and so forth. And so when Aaron is using his sequence, like every sequence, all he's doing is just doing a post with the, that array which determines which lights I should turn on and off. There isn't anything special that's going on. All I do is iterate through that delay and turn the lights off on and off. That happens so fast that you don't notice that there's a slight delay between one light turning on and off. So I'm not turning all 12 on at once. I'm turning all 12 on one at a time, but it happens so fast it looks like, they're all at once. So it's just a bit of an eye trick. And so as for the message piece that's sitting in the middle, that's a second Python program. And originally that was working and polling off SQS, and it does poll that off SQS as well. And we'll pick messages that are coming down. So we had a mechanism where the messages that were coming through were being fed through Comprehend, and based on Comprehend, we were able to determine whether or not effectively the message was safe for work or not safe for work. We were sort of like a little cautious about what that would entail, because I've built some public-facing websites that enable people to publish messages and do these sorts of things that may be published to a bot or publish their own image. And so we wanted to be additionally cautious around what we were doing there. So we implemented a system, and Nelly will take us through that in a little bit, that actually enables us to manually verify every single message that comes through and sets that on. So at the moment, what is happening there is a long poll within a Python app on this Raspberry Pi that connects. That is connecting up to the API and is polling an API to say, API, is there a message ready for me to display, given the time is this point in time at the moment? If there is a message, we'll bring that back, we'll run it for a couple of minutes, and then we'll go ahead and we'll look for the next message. If there is no next message available, we'll go ahead and display that default message. So I know somebody earlier had put through a message saying hello from Chile, and I don't know if anybody else is putting messages through, but myself, Nelly, Matt and Aaron have access to be able to monitor those messages. Now, SNS is used to send out that message. One, it comes to us by email. And so within about 30 seconds or so, we get notification that the new message is ready. We also have a webhook that pushes it out. So the webhook is integrated directly into Slack. So I can just click it and it comes up into Slack. But also that is SMSing that message out to my mobile phone. So if I happen to be out of the office or I don't have Slack connectivity or something like that, I can tap that message on my phone and see that go through. So that's a bit of like the architecture of how we're like building out those messages and allowing that to poll and see that go through. I would say it is not the most like graceful solution at the moment. So the site-to-site VPN, I don't have a redundant VPN connection here, and I don't have any automation because I have a dynamic IP address. It typically changes about once a week. And I don't have any automation to like recreate the customer gateway and reattach the customer gateway if I need to do that. So that did happen before the show. I just basically have to execute a couple of commands to say like, grab my IP address, create a new customer gateway, associate the new customer gateway with my site-to-site VPN, and then do the cutover and delete the old one. It's about 3 steps. I could automate that in the job to go ahead and do that if I needed to. And also for the Flask and Python apps and the Raspberry Pis, I don't have them start on reboot. So there's no like specific job on the machine, the Raspberry Pis that start. So if I reboot the Raspberry Pis, I have to go and re-enable those things. So I did have to do that the other night as well. Look, my power is like very stable. So I've had this up and running for at least a week at a time without problem. However, it was really rainy and there was a lot of weather. So maybe a pole went down and hit a power pole or something, a tree hit a power pole. But the power went out in my whole house, so I had to restart that there.
Paul, you may not know this too, but to add to the complexity, Nelly and I decided that for MVP to get it up and running, instead of me migrating all of the WebSocket stuff into her account, which was then hosting all of the app side of stuff, and then your account for everything you've explained, the actual WebSocket stuff is in my account. So we're actually running across 3 accounts. Okay. So I just hooked up my proof of concept, embedded the code that we needed into Nelly's app. So it's calling from her account where the app is hosted to my account where the WebSocket is to your account where the API is, and then back through again. So that's a thumbs up for a distributed system right there.
Yeah. So, it sort of started off as something fun just to expand it out. And, it's not like a project where we had, look, we're allocated 40 hours in a week to go ahead and build it. We, it was sort of all put together in our our personal time. But it was a fun little application and to put together and to build and play with a couple of different pieces. So maybe Nelly, do you want to take us through some of the code and how you went ahead and did the validation message piece?
Yep, will do.
If you go ahead and
going to
share
my
your screen, I can bring it back up. So has anybody for the audience like ever built something like that streams live sort of like this? Or you know, it's just something along these lines and had to deal with some of the complexities of building a connected device to a home network and explored and played with that. You know, we'd love to hear from you as well.
Okay. So here you can see multiple components. I'm gonna talk about scheduling message. Somebody renamed the title, and I'm not native English speaker. I believe this is the right spelling. Okay. Okay. So there is a repository for UI and for messaging part. So UI lives in Amplify, Devember tree Amplify. And it's all start like a normal React application. So you go on CRC, and there is a app.js, and there is a part where you're going to mine, and there is my message me component. So it doesn't do anything cool. It's just normal form of React, which is just call API in order to post this message. Now, as soon as they post a message, we're going to DevOps component, which is built out of CDK. And here I have all our infrastructure I used, like DynamoDB, API gateway, all Lambdas in CDK. So I don't have to go for console and do anything. So it's all started repository. I even have my repository here built in CDK, so I don't have to run anything in CLI on console. I hate those parts. So I have repository. I built a persistent part, which is a database. There we go. Yeah, it's just a DynamoDB table with the primary key PK. And there is an API, which is just API gateway with all this. Come on. Okay. So there is API gateway with all integrations. And the interesting thing, when we post a message, there is no Lambda in between API gateway and DynamoDB. It's just using straight integration with DynamoDB. So I have this wonderful template which transform the request from the REST request to DynamoDB. There we go, this one, DynamoDB in put item table. And of course, I have all my permissions here right away, right there. So I don't have to go anywhere else. Okay, so as soon as it's in a DynamoDB table, I have a trigger notification because I didn't want to have Lambda. I want to, message get onto DynamoDB, and then I was using DynamoDB streams to notify the rest of us and do the thing. So I put this Lambda. Let me find out where I described it. So I have a Lambda here with the roles. It's a trigger notification, and here we go. This is hook this Lambda right to the DynamoDB strings. Yeah. And then a batch size of 5. Font size. Oops. Is it better? Yeah. So this is hooking up DynamoDB table. And if we go to trigger notification Lambda, which is hooked up to this, it just
Nelly, could you just put the font size up a little bit, zoom in a little bit?
I just did. Should be even bigger. This one. Okay, good. So this is just mess of JavaScript. If I would be in the real life, right, I would write unit tests and put a function, but here we are uni project thing, and it says if there's a new record, basically an insert, just push this to SNS, right, to notify everybody who interested. And then when we decided we need to Slack integration, I just built it to Slack, and it's just a webhook. Okay. And that's basically it, to be honest. That's simple, just a few components. So message coming from client to API gateway to Dynamo, Dynamo sends it to Lambda, Lambda distributed to SNS and people who need it. Yep. Do you guys any concerns, questions? No?
So, like, what way do you want to use like VTL and directly connect to Dynamo over Lambda?
Well, I didn't want to write Lambda, extra Lambda if I didn't have to, right? So in my my trigger notification, there's an API, yeah. It's just a VTL template, just create, put an item. Right from here, simpler. VTL is not perfect, right? But it does a job. How would you architect it in a different way?
No, I wouldn't. Sorry, I'll just. I had some feedback in the background. So maybe Aaron, maybe you can take through your how you implemented some of the code on the WebSocket.
Yeah. There's not a lot. Not a lot to show. Let me just pull up.
Yeah, somebody asked how you can know who sends signal to Raspberry, and we build this application in a way so we don't. So it's you're absolutely free to do that, and nobody gonna stalk you and invade your privacy.
Who sends a signal to the Raspberry? So that's the WebSocket app actually sends the signal to the API that's in Paul's account, which then the data captured from that API is sent through to the Raspberry Pi. So it's all fronted by the REST API. I'm just looking for. I have Nellie's code. I don't have my code open.
So, and maybe just to clarify that that the way you send the signal to the Raspberry Pi is like I have a public application load balancer that will enable you to post directly to the Raspberry Pi. So maybe I'm not sure if I have that on this computer in Postman, but there's a public load balancer that enables you to do a post directly to an application load balancer. And because that application load balancer has a target group, and that target group has a member, which is a Raspberry Pi on my premise, you can do a public post directly to that endpoint, and my Raspberry Pi will interpret the body of that response and then go ahead and turn the lights on and off. So I think I have that up, and I can show that in just a second. So I'll try and look for that as well. Yeah, I do. I can share my screen while you're getting your stuff together, Aaron.
Yep, I am just selecting the screen.
So if this is how it looks, so feel free to go ahead and try it. But you do a post to this on-premise application load balancer that sits there, and then you send across, like, the body of that is just looking for an array. So if I was to go ahead and send that, I would expect the top light to go on and every other light to go off. And if you're watching the stream, you would see that would have changed within a second or so. And if I was to go ahead and send that again, then I would see the third light to come on and off. So that's how you're sending those responses to the tree directly over the internet. There is no authentication on that. It's kind of open for abuse. So if somebody was to write a script that was to call that thousands and thousands of times, it would do that, and it would send that all the way to my premise, and I'd see those lights flick on and off as fast as possible until the Raspberry Pi gave up. As for the message is the other way. So the message has the Python app on the Raspberry Pi that is constantly polling the AWS resource to determine whether a new message is ready to come up. And so the way that Aaron is calling this is his application is effectively taking arrays of this array and then calling my API multiple different times on top of that. So it's all like an extended facade on the top of it. So in effect, the way Aaron is doing it is something like this, where that body would look like that.
So you're not actually sharing your screen at the moment, Paul.
Oh, did it again. So sorry, everyone. I'll quickly undo what I just did there. So yeah, so this on-premise URL is what I was talking about. So I'm doing a post directly to that. The body is expected to be this array. I'll do that again. If I send that across and I change one of these values, we'll see on the stream that those lights are turning on and off, and that's all we're going ahead and doing that. If you wanted to produce a pattern or your own pattern or Morse code or something like that, you could go ahead and write your own script, a shell script or something in any sort of language to call that multiple different times and turn things on and off. So, that's how you could go ahead and build that. And that was the idea behind Aaron's, DSL that calls all of that multiple different times.
So if you want to share my screen, I can take you through the code on both Nellie's app that talks to the WebSocket and also the WebSocket. But actually, before I do that, I will show you. So the WebSocket itself is very simple.
Maybe
so the question,
make it bigger.
The question before, why is this not zooming? There we go. The question before was like around why are you storing the let's close that. Why are you using DynamoDB basically? So on connect and on disconnect, we're storing the session. So the session is essentially understanding the connection from a client to the server so that we can then send back from the server to the client. So we need to store that session somewhere that's not ephemeral. So it's not actually going to be disposed when the Lambda finishes firing. So on connect, there's three main Lambdas to the WebSocket. There's the on connect Lambda, which takes the connection information and stores it in the DynamoDB. There's the disconnect Lambda, which does basically just the exact opposite. It deletes the record for that session ID. And then there's the actual post. So this guy here is the one that's doing the work. And what it's doing is it's receiving, so on the actual handler, if we go down to the handler, it's establishing so it's pulling all of the connections from the DynamoDB, and then it's establishing a promise so that it can go through the promise and fire off every single, I guess it's a request or a response back to each client through the promise. So that's where at the end here, we do the promise all and post calls. The post calls is that collection of promises, or the collection of, for every client, we want to send the response for this is the button that was sent. So all we're doing is we're receiving the message through the WebSocket for where are we? For the actual data, so the actual buttons that have been pressed, cycling through. So the post data is the actual data that's coming from the post to the WebSocket, cycling through all of the customers or all the clients, that we want to connect to, and then firing them off. Then we actually send. So I could have used, this is Node.js, so I could have used HTTPS from the Node.js library instead of adding Axios to this Lambda, which would have probably made it a lot simpler. But I wasn't thinking that at the time because I basically just wanted to use a very simple, instead of having to write my own little function to send it off. So I just used Axios library. And all I'm doing is posting that data, so the array that Paul was talking about, to the tree API. So the tree API, obviously storing it as a variable. And that's it. So that goes through, fires it off so that all clients receive the same command, and then we send it to the post API. That's the actual WebSocket side. From the client side, so there we go. I've structured it so that so the tree and the DSL are essentially separate components within Nellie's React app, but they both want to share the same WebSocket hub. So essentially within the app itself, so the React.js app, I established the WebSocket hub by again, the URL to the WebSocket Hub is what do you call it? Environmental variable. When the actual application loads, so using effect as a React function component, not a React class component, this is where I use the native JavaScript library to set up the WebSocket. So we create a WebSocket hub, which this essentially does all of the connect, disconnect, on close, on error, on receive message. So this hooks up everything required to send and receive response, to send to and receive responses from the WebSocket. So on message, this is then where we set what we do with the actual the message received from the WebSocket. So then I can actually abstract that out. If I see set web message, what are we doing here? Payload send. All right. So the actual sending of, so all we're doing here, because everything that we want to receive from the WebSocket is what are the images or the lights that are on, all we're doing is changing the state. So when we receive a message, we're just using the set WebSocket message, which is actually just updating the state in the React app, and then that state is handed through to the actual components. So the tree component is the only one that needs to display the lights. The other payload, so the WebSocket send, is abstracted out so that we can send from both the tree and from the DSL. All it is just a wrapper around the actual WebSocket send connection, and then it's just in the right format that the actual WebSocket's going to receive. So the tree is as simple as, where are we? So we're using a reducer. I won't go too much into the differences between the state and reducer, but this helps us to maintain the state with lots of messages coming in, as opposed to just updating the state. We can go through and check the current state, check updates to the state, and reduce the actual scope, or the state within scope. Where are we? What I'm looking for is, so dispatch is going to use the reducer. The reducer gets fed the WebSocket, and so the WebSocket actually is handed through the reducer through the actions, and then that's it. We basically just send to the socket, and that goes back out to the one we saw before to send the state of that array, and that's your lights on the click button. As I said before, the actual the DSL is very simple. It's just a second step timer. So I was using what do you call it, the Windows or the browser's native animation frame, but I, for some reason, was having difficulties with the animation frame not actually firing according to when it should fire. So I haven't actually looked at debugging that, but to get rid of that, I just went over and created a simple set timeout. And so for every second, it'll then fire off, and then it'll check, what is the type that we're firing off? Is it a auto that we've received? What are we going? Sorry, it is an auto. If we're at the first, we want to send blanket all, so turn off all. If it's at the end, so we've gone through the animation, then turn them all off again. Otherwise, step through and increment through the array that we've handed through the actual the DSL. And all I've done, it's very simple, is just simple get the line, so line by line, split it into lines, and then send it for each line. So there, obviously, if we were going to go into production, there'd be a lot more validation that you'd put over this to make sure that people aren't putting funny characters in the array, or that it is the array and not putting, whole sentences and stuff. At this stage, it'll just quietly fail if you put anything other than the array. But then the next person to put through the array will just fire it off again. It's all very simple and straightforward.
Yeah, I think that's the same as because and we'll come back to Focus Artist's question about using Amplify in a second. I'll just address the how we display that message. So I'll show that really quickly as well, and I'll share that code. So it's actually like much simpler than you would expect. So here it is in a little terminal. I don't have like this code local onto my machine, and I'll bring it up. I won't forget this time. But effectively, like, all of those pins are mapped using a specific library. So I'll scroll up and I'll show the library that's used. It's this Lumina Core LED matrix device library that enables you to only use 4 GPIO pins from the Raspberry Pi, but that enables you to turn on, there's like, 100 tiny little LEDs that form the basis of displaying those messages. And there's a number of features that are available to put that out. There's a number of different fonts that you can display on there as well. And of course, those fonts are going to do the best effort you can. You can change like the size, the intensity of the lights, the backgrounds. You can't change the colors because it's just red on this one or not. But basically, the way it does is all I'll do is just like in a loop, call that API, which is the API that determines whether or not a message is available for me to pull next time. The only message that will surface is an approved message that will come from the API that Nelly put together. Then as part of that message, I'll look at, pick out the text from the JSON. If there is no message there, we go ahead and we just, display Merry Christmas from AWS, whatever that might be there. And we display that. Now, somebody was passing in some funny characters at some point in time, and that would cause the app just to crash. So I just, basically just put it in a try catch. If someone passes something through, like, an emoticon or something like that, it will fail. It doesn't know how to handle that, and it will just say exception occurred. But effectively, like all of the real core logic is in this while loop. So basically, while true, just loop forever. Just poll that API and determine whether there's a message for me to display or not. And after each iteration of the message, check whether there's another one to go ahead and display. We also had that hooked up to SNS when it had some of the other services earlier, but just for speed of simplicity at this point in time, it's polling that API there. I'll stop sharing my window, and maybe we'll go and look at
just Paul. There's a couple of questions around how much does this all cost.
Maybe we'll come back to that in just a second, and maybe that's a good segue into like using Amplify. So Nelly, like, why did you use Amplify originally for this?
Well, first of all, I want to try how Amplify plays with CDK, right? Because I'm a CDK fan and just wanna see how it's going. It is really easy, just a couple lines of code, and Amplify is there, and you can deploy. Second of all, because time constraints, and like I just wanted something that built for me in the best possible way, opinionated code pipeline and all that stuff. I didn't want to build it myself. So Amplify just did it for me very quickly. I just didn't need to like learn anything. It just works.
So, and I think that's look, we do talk about Amplify quite a lot. Like, I would say, how many like massive projects have I done that have built Amplify and use the Amplify pipelines in production in comparison to your own custom built pipelines? I would say it's because I'm more in the enterprise space, kind of a lot more end up being like highly customized, but it takes a really long time. But I've also spent a significant amount of time working with customers that are still in the early stage, or they're still, looking to move away, towards some modern practices, and they just don't have the resource to invest in like rebuilding their CI/CD infrastructure. They want something simple. They want something reliable and scalable. And, Amplify is excellent for that. So in the diagram, when we saw CloudFront and S3, that's abstracted away from us. We don't see that distribution being created and built when we deploy our application and distribute it with Amplify. However, it exists. It is there for you. You just don't have to deal with it and see it. So it makes it much, much simpler to be able to do it. As for the question, were you referring to 41 Wolves question, Aaron? How much does this cost in comparison to AWS Chime?
No, it was the one just above that. How much is the billing?
So somebody asked me this a little while ago, and I would say the whole solution, from my point of view, the most expensive piece to keep up and running is that site-to-site VPN. So keeping the site-to-site VPN and the customer gateway up all the time is the most expensive piece. And I think it was something like $45 a month or something to keep that up. Now, obviously, I've got a Raspberry Pi running all the time. And there's, some bandwidth going backwards and forwards. And so then that's the most expensive bit. Like Lambda, that's pay per use. DynamoDB, again, is on pay per use. And that'll be on I assume at the moment it's on demand. So, it'll scale up and down as required.
It's on by default.
Yep. So like that's going to be like a pittance. So I would say for what we have done, this whole piece and Aaron's piece and storing the data, the cost of the storing of the data in DynamoDB, you know, like I would, you probably couldn't calculate it in a calculator. It's so small.
I can tell you that since I had the DynamoDB and the WebSocket up and running over the last month, it's cost me 12 cents.
12 cents, yeah.
And that it's usage based. So obviously, maybe this month it's going to be a little bit more because we're demoing it and lots of people are using it. But I can't foresee it going over like $10 maximum. You know, it's going to be really small.
Yeah, that's exactly right. It's like it's super low. And I have the site-to-site VPN on anyway. You know, there's always cheaper ways to do that. And I guess like, you know, the ability to post directly from the internet to that Raspberry Pi would be, you know, you don't need to have it that way. Maybe you could poll it the other way and have a polling loop, and that you know, you could avoid that cost. But I guess like that's the most expensive bit. Having an always-on VPN connection is a little expensive.
Can I say this is pretty much our job. If people out there want to figure out how to come up with different solutions to solve, you know, like if it's billing and you don't want to use a site-to-site VPN, reach out to us. This is actually what we do for a job. So, you know, like we can help you come up with a solution to solve that problem if your business is, you know, or if you're a home dev who wants to solve this as well. You know, reach out. We love solving these things with you, and we can help you solve let's do it, to Paul's example, you know, let's do it as a polling mechanism so we're not having that expensive site-to-site VPN up and running, or, you know, whatever you want to solve. It's just funny because this is what we do for a day job. So.
And expensive is like, it depends, right? Like $40 a day is expensive for me at home. Yeah. Sure. Like I don't want to be spending that, but it might not be expensive for, you know, the solution that you're implementing. If, you know, if you want to do this as a gimmick for your store for Christmas or something like that, then $40 is a minimal amount of, you know, cost to pay.
Yeah.
So I did paste in that, and that answers somebody's question. I think 41 Wolves, will it be available on the Editors channel? Yes, the video will be available for, I think it's about 3 weeks or so, but also all videos are archived on the Devs in the Shed YouTube channel, which I've pasted in there, and it'd be great if everyone could subscribe to that as well. So we do have you know, content coming out constantly. So maybe before we recap, did anybody, even in the audience, have what was your favorite announcement from Reinvent? And maybe Nelly and Aaron, what was your favorite announcement from Reinvent?
I really love this SageMaker canvas, right? I was learning machine learning for some time. I was learning machine learning, yeah. And I started from the ground, from the math, from the graphs, and never get to apply this. And now it's so easy, right? Even I, with my little mind, can do that. So cool.
Yep, I think so. Aaron, do you know what yours is, or do you want me to go with mine?
You're right. Mine's a simple one. It's just a CDK overrides in Amplify. Like, to me, that is a very powerful thing. A lot of the customers that I work with are doing like app migrations, and they want to take advantage of both Amplify, or they've done something in Amplify and they want to start taking advantage of CDK to like build it out into a larger distributed system. Just having those overrides, it's a small thing, but it's very powerful.
Yep. And I think mine would be, and we've talked about it and we've been on the show a number of times talking about it, would be CDK v2 is now generally available. So I think that's like, you know, just excellent. I'm really pleased that that's come out. You know, managing those dependencies and not having to worry about that is like fantastic. I've already had customers this morning saying, how hard is it? Like, what can we do? We want to migrate because we're sick of the pain of that before. It's a reasonable, easy thing to go through. I'll paste in a workshop and a lab that we've been working on internally to build that. So this is a publicly available lab. So it's an extended CDK workshop that helps you take you through the process of migrating an existing app into like V2.
I already used it. So cool. I already migrated my stuff on my pet project to 2.0.
Yep.
Thank you.
Yep. And we're almost at time, but maybe we'll just look at Focus Otter's last question. Am I understanding right that API Gateway and App Sync are being used, or are those two different apps?
I used API Gateway, yes, but didn't use App Sync as trying, but didn't succeed. Probably.
So I'm a big AppSync fan and use it often. Obviously, AppSync Subscribe is very similar to WebSockets, but no, in this case, I was using API Gateway for WebSockets.
Yep. Yeah. So thanks everybody. Oh, actually, Amplify Studio. That's another one as well. Like I can't believe we didn't think about saying that. So yeah, I think that the new we'll for sure we'll be doing a session around some of the new announcements around Amplify and developer productivity, being able to take your mock-ups and be able to work through those. I think that's pretty.
Figma integration. That's the best thing ever. I'm sorry, I'm hijacking.
So yeah, and yeah, just to close off, like JW1 said, they had 850 lambdas and 50 billion requests per month going through API Gateway, and they saw their costs at around $100 per month. So mileage will vary on how long you're using your, how long you're holding those requests open and what sort of size you've got and what sort of savings plans you've got. But yeah, the cost is significantly good, and also 5G private networks is pretty awesome as well. So yeah, thanks everybody, and thanks extra to Nelly and Aaron for coming along and working over the past month as we've gone backwards and forwards. Go ahead and play with the solution yourselves. Reach out to us, subscribe on on YouTube, and reach out to any one of us on LinkedIn if you need to contact us. And we'll see you again next week. But yeah, thanks all. Have a great week.
Thank you.
Bye.
Bye.